Hi Professor, I'm Sumant. Today I'm going to explain about the software called Apache Lucene. As you can see on the screen, these are some basic contents that we are going to discuss in our project presentation. So our presentation goes as follows. First, we will know about what is Apache Lucene and its basics, followed by search and different types of ranking algorithms followed in Apache Lucene. At the end, we will also know about different types of real-world use cases and advantages and some of the disadvantages associated with Apache Lucene. So before we begin our presentation, let's start about knowing what is exactly is Apache Lucene. So basically, Apache Lucene is an open source search program which is written in Java with powerful searching and indexing capabilities. And it also plays a significant role in building search engines and used in various industries like e-commerce and data companies, etc. Basically, Apache Lucene is written in Java, but it's quite compatible with other programming languages as well. Now, as we move forward in our presentation, let's discuss about the basic working principles used in Apache Lucene. The process starts by query parsing, which involves in creation of structured representations for matching and executing the query for the contents of the documents that we provide. And it uses some important factors like term frequency and document importance factors, etc. Now coming to the second part of the process, it is scoring and ranking. As a result obtained by the running the above query, each document gets a score based on the query conditions that we provided earlier. In generally, high score tends to mean the high relevance of documents. Additionally, Lucene provides real-time indexing and ranking. This means that during the execution or after the execution of the query, if we add any additional data or documents, the Lucene quickly pre-processes the data and provides the updated results, including the additional data that we provided. And coming to the different scoring algorithms that we used above, there are like quite different types of algorithms that are available for the customer to use. So he can choose based on his requirements. Now, as we discuss the basic components used by Lucene, let's see how this works in real time. Let's consider the examples code that you can see on the screen. The first part of the code contains index creation. As you can see in the code, the memory index is created by using a RAM directory, which is a type of Lucene directory that stores index in the memory. Coming to the second part of the code, we can see the document indexing. You can see the documents were indexed into the Lucene using a index document method. In our code, three documents are added, each with an identifier, a title, and a content. Now coming to the important part, a query definition. A query is defined using a query parser. The query parser is configured to search the content field using a powerful search query string. Now this basically means that it retrieves the documents where the content field contains the powerful and search words. Now moving on to the other slide.
I'm Ramsha Shankar and continuing from here. Basically, Apache Lucene has index creation, document indexing, index writer, and index searcher, and query definition. Index creation is nothing but it is created using a RAM directory, which is a type of Lucene directory that stores the index in memory. Document indexing are indexed into Lucene using the index document method. Three documents are added, and each with an identifier, a title, and content. Index writer is used to add documents to the index, and the index searcher is created to perform searches on the index. Query definition is defined using the query parser. The query parser is configured to search the content field using the powerful search query string. In search execution and ranking process, the search method is called on the searcher object with defined query. It retrieves the top 10 matching documents based on Lucene score algorithm. These are stored in the top docs object. For ranking, we have imported the BM25 similarity class and set the similarity of the index writer configuration to BM25 by using config.set similarity new BM25 similarity. This instructs Lucene to use the BM25 ranking algorithm. I included the scores associated with each document which represent their relevance according to the BM25 algorithm. This code uses the BM25 ranking algorithm to rank and retrieve documents based on the query's relevance. You can explore other document ranking algorithms in Lucene by changing the similarity using in the index writer configuration. The process of ranking search results involves TF-IDF, vector space model, best matching 25, field boosting and custom similarity models, relevance feedback, and advanced ranking features. The TF-TF is Nothing but term frequency inverse document frequency, which calculates the score based on term frequency in documents and inverse document frequency. And this process assigns higher scores to documents where query terms are more frequent but less common in the entire corpus. Vector space model represents documents and queries as vectors in a multi-dimensional space, and the ranks documents based on the cosine similarity between query and document vectors. Best matching 25 is a probabilistic model that factors in term frequency, document length, and term saturation. It also balances term importance and document length normalization. And field boosting and custom similarity models allows you to assign different weights to fields or terms in a query. And the custom similarity models enable tailoring the ranking algorithm to your specific needs. The relevance feedback user is nothing but user feedback can be used to refine search results by marking documents as relevant or irrelevant. And also it adjusts scoring for future queries based on user interactions. And the Lucene offers features like filtering, pasting, boosting, and highlighting to fine-tune search results. There are some additional scoring algorithms that those are classic similarity, IB similarity, DFI similarity, Boolean model, and payloads. Classic similarity model uses a simplified version of TF-IDF to calculate scores. It incorporates term frequency, inverse document frequency, and field length normalization. IP similarity is information-based similarity. It is based on the information theoretic principle of Kullback-Leibler divergence. It models the likelihood of generating the query from the document language model. And the DFI similarity is divergence from independence. It is another family of scoring models in Lucene that extends the DFI approach. And the Boolean model is, while not scoring a algorithm in the traditional sense, Lucene can be configured to use a Boolean model for matching documents. In this model, documents either match a query term or score of 1 or do not score of 0. It's useful for exact match scenarios. And the payloads are metadata associated with terms in document, which can be used to influence scoring. Developers can define custom functions to score documents based on the presence and content of payloads, allowing for fine-grained control over relevance ranking.
Hi, this is Charan. So now I'm talking about customizing ranking in Lucene. Customizing ranking in Apache Lucene involves tailoring search results to specific requirements and preferences. While Lucene provides default scoring models like TF, IDF, and BM25, customization is necessary when these models doesn't fully meet unique scenarios. Developers can define their own ranking criteria, including factors such as term frequency, inverse document frequency, field boosting, and more. By creating custom scoring models, developers can influence the ranking process to ensure the most relevant documents appear at the top of the search results. The flexibility is particularly crucial in use cases such as e-commerce product ranking, content recommendation, and personalized search. Delivering highly relevant results enhances the user experience and the overall success of the application. Customized ranking allows for better alignment with specific business goals and user expectations. In this slide, we are talking about the use cases of Lucene. Apache Lucene is indeed a powerful open source search engine library that enjoys widespread adoption across various industries. It serves as the backbone of search and information retrieval systems of many leading companies. Notable users of Lucene include renewed names such as Netflix, while relies on it to power content recommendation system. LinkedIn leverages Lucene to facilitate professional networking by enabling efficient search functionality. Utilities Lucene for efficient financial data search enhances its services for users in the finance industry. Lucene versatility extends to e-commerce giants like eBay, where it enables product search and recommendation systems, contributing to a smoother shopping experience. Digital publishers like the New York Times also benefit the Lucene by enhancing their own online search functionality, ensuring users can easily access relevant content. The effectiveness of Lucene is not limited to specific sectors, rather, it finds application across e commerce, social networking, finance, content management, and more. Its robust features and customizable capabilities make it an indisciplinable tool for delivering accurate and relevant search results across various domains. Now we are discussing about the advantages and disadvantages of Lucene. Advantages: high performance, open source, customization, and scalability. High performance. Lucene is well known for the expression speed and efficiency, delivering fast search results even when dealing with large database. Open source. As an open source project, Lucene is freely available to anyone. It is not only reduces the cost for organizations but also fosters a vibrant developer community. Customization. Lucene offers extensive customization options, allowing developers to tailor search functionality according to the specific requirement. This includes fine tuning ranking and the score models to ensure the most relevant results and presented to users. Scalability. Lucene is designed to scale efficiently, capable to handle massive datasets and distributed environments. It ensures reliable performance even as the volume of data and user query increase over time. Now we can talk about the disadvantages. Some of the disadvantages are complexity, maintenance, lack of real-time updates. Complexity. Setting up and configuring Lucene for specific use cases can be complex, particularly for users who are not well versed in such technologies. Understanding the various configuration options, indexing strategies, and query optimizations may require a significant learning curve. Maintenance. Maintaining a Lucene based system involves ongoing effort and expertise. This includes tasks such as updating the library to newer versions, optimizing indexes for performance, and troubleshooting any issues that may arise. Without proper maintenance, the system performance and reliability may degrade over time. Lack of real time updates. Lucene default indexing process is not optimized for real time updates. While it excels in improving fast search results in pre indexing data, it may not be suitable for application requiring immediate indexing and retrieval of newly added or updated documents. Implementing the real time updates with Lucene often requires additional customization and may introduce performance overhead.
As you can see on the screen, the key points that we discussed about the Lucene are listed below. To sum up on our discussion, Lucene's pivotal role in indexing and ranking and its customization abilities makes it the most reliable software for searching and ranking. And thanks you for giving this opportunity to present myself.